Thank you so much for coming. We're so excited to have you. We're going to flip the order real quickly. Charity's stuck in traffic, but she is on her way. She's probably parking right now. Oh, she's literally walking in right now. Sweet. Welcome. So happy to have you. We'll let you catch your breath, grab some pizza. Yeah, right there. Grab a drink, help yourself. Quickly wanted to introduce our first presenter, Saoirse, and also introduce to you who we are and welcome you to our office. Before I start with that, the bathrooms are right here. If you would like water, that is directly behind you in the kitchen cafe area. And if you do have any other questions about this office, let us know. We are SmartBear, so we do software quality tools for teams. So we have tools that span the entire SDLC from development, testing, through operations at both the UI and API layer. Should we turn down the music? She's working on it, okay? It's our first time. Well, not like the company, it's just ours. And so you might know us for Soap UI, you might have heard Swagger and a ton of other tools that we do have across our entire portfolio. We partner often here with the Ministry of Testing. I'm a co-organizer. I believe we have another co-organizer here, and we do have a few others with us at SmartBear. So we're really happy to have you, honored to have Charity, and honored to have a lot of you here in our presence today. So with that, going to go ahead and introduce Saoirse, who is one of our marketing members and is going to be talking to you about Westworld and how that fits into software quality. I'm not sure yet, but we'll see.
Thanks, Bria. So again, thanks so much for showing up. I know that you guys probably are wondering who I am and why I'm talking about this today. So just to give you guys a little bit of background on who I am and why software actually came into my life, because I know that everybody hears marketing and you're like, oh God, don't send me any more emails. I'm like, I know, I'm working on it. So really to just give kind of context to, I don't really need this, I guess. It's just a picture of me, so you guys can see me here, so it's fine. I originally started out my journey at a company called HGH Infrared Systems, which make the big, large infrared cameras that you would sell to companies, mainly the government, so like the Department of Defense, Navy systems, anything like that. And that was kind of where I first was exposed to technology in general and the importance of development and working with different types of teams and how you should communicate between those teams. I worked with them basically to launch a new product, which was a smaller version of the camera that they have. So how can they get into new markets, who would care about this product, and how do we talk to those people and basically bridge the gap between the people who are coming up with the features and the people who would actually use this in everyday life. And like, what would their issues be, what would their challenges be, and how can we make sure that what we're doing and what we're producing will actually help them, as opposed to like, hey, we have this really cool new feature, and then it comes out and nobody uses it. So really trying to make sure that we communicate that well. And then from there, I actually joined a small software company called Conciliant Software, which back in the day was owned by Xerox. We had one product, it's called Maven, which was a configurable case management system. So if you guys are familiar with, I think a couple years ago, when we had the Ebola and Zika outbreaks, basically what Maven did was helped some federal deals, but mainly state and local governments track and manage those outbreaks. So for example, Massachusetts used it for the Ebola outbreak and New York City used it for Zika. So it was super instrumental in trying to understand how can we make sure that the software that people rely on every day is actually accomplishing the job that we need to get done, and how can we make sure that any gaps that we have in terms of like interoperability, connecting with other healthcare systems is closed so that we're doing the best, most efficient possible job that we can. So that was super cool. Definitely wasn't something that I was ever thought that I would get into, to be quite honest with you. But it did teach me a lot about how different types of teams work, and sort of the silos and challenges that come with that. And then on top of that, how different, I guess it is, going from kind of being in your team or development bubble versus like what people are saying on the outside and what they need. So I kind of helped bridge that gap there, which was really, really cool. something that I really enjoy doing. And then obviously, I work at SmartBear now. So I work on 2 of our product lines, one being AlertSite, which is our synthetic monitoring tool, and then our newest release, which is Load Ninja, so it's a cloud-based performance testing tool. Super cool because we test in real browsers, which is not something that's common, and it's super easy to use. So I kind of have this interesting challenge now of, okay, how can I make sure that everything that we're doing is relevant, it's going to help, and how do we make sure that since we are in like a very mature space with a brand new product that does something completely different, how do we make sure that we can ease people along without people being like, oh, this is too different, like this is radically like different from what my processes are, is it going to work, and sort of helping to quell that fear of trying something new and implementing a different type of tool than what you currently would use, if that makes sense. So I'll see if this clicker is working real quick so that you guys don't have to stare at that all day. Okay, so that's me. I kind of went over this though, so we don't have to deal with that. So Bria gave you guys a little bit of an intro for SmartBear, but I just wanted to, sorry, I turned that off just then. I just wanted to reiterate, just for those of you that aren't familiar, we're a pretty big company. We started in 2009. Now we're up to 11 offices. We have a ton of different tools. And essentially our goal is to make sure that you can inject quality into every stage of the software development lifecycle without having to slow you down. So I know that a lot of people are familiar with Swagger or SOAP UI. Those are kind of like the 2 top things that people are aware of. We also have a variety of different tools that span across the entire software development lifecycle. I won't go too much into these, but I just wanted to give you guys a little bit of a feel for who we are, what types of tools we make, and what we care about. So without further ado, I wanted to talk about 2 things today. So first thing being software quality, and then observability. And I know that a lot of the talks that I've attended in the past are more tools focused. This is not that type of talk. My experience really is understanding how teams work and how you can make sure that those silos that sometimes are physically there and sometimes are like mentally there where you're like, oh, they don't work on my team, so I don't talk to them about XYZ, how to break those down in order to become a more efficient and ultimately better working team. So don't worry, I won't read you this whole thing about what software quality is. I actually cut it down just to point out what's important. So software quality really, to me, is defined by how well something complies with functional requirements or specifications and how well it meets non-functional requirements. So things that are a little bit more soft, where it's like robustness or maintainability, things that are more preference-based from a user perspective. And I kind of broke it down into 6 things. I guess you can call them like 6 pillars of software quality, right? So first things first, obviously it has to be functional. You don't want to buy a tool that doesn't work, end of the day. It has to be reliable. So part of that is being consistent. I think if you're able to have a tool that you know is going to function in a particular manner and you can rely on the fact that that's what's going to happen, that's something that people would expect from a quality tool. The third thing is that it's usable. And this is kind of an open definition. I think a lot of people have different experiences of what would be usable and what's not. But overall, if you're someone that knows what the tool should do, you should be able to use it at the end of the day. The fourth thing is that it's efficient. One of the things that we recently did here for our Ready API tool was, which is basically our API, I guess you would call it a suite. You have SOAP UI, so for functional testing. You'll have Load UI, so to load test your APIs, and then we have Service V in there as well. And one of the things we did is we evaluated like, okay, we know that we have a really robust tool that can do a lot of things, but at the end of the day, can everybody get to those things that they need to do? And so we actually cut down, I think there was something like a crazy amount. I really don't even know if I should admit how many screens there were, but there were a lot. So I want to say over or around 50 different screens that you could get to within the Ready API platform. And at the end of the day, we were like, is this something that is going to be helpful? And we found out that it wasn't, obviously. People need to be able to get to things in an efficient way. So we were able to narrow that down, I think, to around 15 pages now. So everything is super accessible. You don't have to jump through hoops to get to the information that you need. The fifth thing would be it's maintainable. This is kind of an interesting term as well, especially we're kind of in the age of SaaS products where everything is sort of put onto the cloud provider to support that. But at the end of the day, as long as it's something that you can physically maintain and it's not something that you have to spend time making sure is working on your end and putting in a lot of effort to make it work, you should never have to do that, especially if it's something that you purchase, right? Like it should be something that you can rely on, you know it's going to work, and you can continue to use. And then lastly, I put in that it was portable. So by portable, I don't mean you can physically pick it up and move it. I mean that you're able to use it sort of in different ways than you think that you can. So if you have, for example, a piece of code that's used for one function, and you're going to do something similar down the line, you should be able to take that and reuse it. That's more on the, I guess, the back end of software quality, so looking at it from a vendor perspective, but I still think it's something important to be called out. All right, so finally, I think a lot of people have different definitions of observability. It's almost kind of like a buzzword that's gone around within the last couple of years, but technically the definition is really trying to understand the measure of how well the state of a system can be inferred by the outputs that it produces. And so from our perspective, or from a software perspective, the way that I like to look at it is really being able to understand or really have access to insights that can help you change what you're doing without having to basically rework the wheel. So what I mean by that is basically being able to make sure that not only are you having monitoring outputs, so things that you can predict to fail, getting insights from that, but also collecting data along the way so that when something does go wrong that you aren't really aware of being a problem until that moment, you're able to then go back in and fix that. And I have this picture up here from an article. It was a Medium article that a woman wrote. Her name's at the bottom if you guys want to check her out. I really like her work. That I thought really fit well with a lot of the things that I've personally seen. So what she was trying to explain with this basically is that observability is it's not a singular thing. It's a process. There are a lot of elements that go into that, but from a software perspective, being able to test and monitor in conjunction with one another to really amplify the feedback loops that you get will help you understand what's going on with your system. And I thought that was something that's really attainable for a lot of people. I know that I'll get a little bit into this in the next slide, and I'm sure Charity might agree with me, or might disagree with me, but that's okay too. I think that if you have testing and monitoring tools in place and you're not using them in parallel, it's something that you're kind of doing yourself a disservice, where if you do that and you're able to instrument that properly and continuously get feedback throughout both of your teams, if they are separate teams, whether or not they may be the same person, you'll end up being a lot more successful down the line. So I know that this comes up a lot as well, where people are like, well, if you're just getting data back from what's happening in real life or in production, why is that not monitoring? And so it's a fair question. I think the key difference here is that monitoring is, by nature, your ability to monitor or to gain data or gather data based off of situations that you already know are something that should be important, if that makes sense. So that can help give you insight on the overall health of the system, whereas observability really helps you get granular insight into what's going on with rich context. So whether it's events, logs, detailed things that you have access to dig through to say like, oh, I didn't know that this was something that could have gone wrong, but now I know what's happening and I can go back in and fix it. And I actually think it's a combination of 4 things. So obviously, monitoring is super important. It's really helpful, especially if you have some APM tools can help with some of the other elements here as well. But your ability to monitor what's going on in production is obviously essential. Then your ability to alert on that and really sort of visualize or surface up, hey, this is where this process broke down. This is what you should look at or call attention to. And then the last 2 things, which I think are really, really essential for basically achieving observability, is making sure that you have access to log aggregation and analytics and a distributed systems tracing infrastructure in place. Those are kind of the elements that help you uncover, for lack of a better word, like your unknown unknowns, right? Which kind of seems counterintuitive, but really it does help identify those. And so I think most people will know why this is important, but I like to call it out anyway. And I think, just to give you guys a bit of a context here, so I'm going to use Westworld as an example. Just to get a show of hands real quick, who has actually seen Westworld? Okay, good. So more than half. I was talking to people before I did this, and they're like, well, yeah, I know what it is, but I've never seen it. And I was like, oh, God, no one's going to know what I'm talking about. So Westworld is a show on HBO. It's based off of the idea that you can create almost this real-life theme park, essentially, where you can interact with these things that they call hosts. So they're computer systems that look like us, talk like us, all that good stuff. But obviously they're not actually real. So Delos, which is the company that owns the Westworld park, has a bunch of different types of parks, right? So they built this like amazing world, almost like if we could have an adult Disneyland, that's kind of the vibe that they're going for, where you can kind of explore all the things that you can't do in your actual life. Most of the time, it's not things that are very nice, but that just is what it is. Unfortunately, people like to do stuff like that. So their team did a lot of things well, right? They made an amazing experience. They obviously came up with technology that was incredible, especially for, well, even for this time, we don't have things that are like that. On top of being able to design the software behind it, so I'm sure there's some level of machine learning here where you have like, okay, if someone interacts with you and says this is what the response should be. This is the, what was the word that they used? Like the narration or the storyline that they should be following. These are the points they should bring up. This is the level of emotion that they should show. So there's a lot of things that were really, really incredible that they did. But they did do something wrong. And given they did do this on purpose, or at least one member of their team did this on purpose, but there was an update that was released called the Reveries, which essentially allowed a select number of hosts to basically override all of the things that the rest of their team thought that hosts could never access. So the ability to realize that you are not in the real world, that your world is almost synthetic, if you want to use it for that term. The ability to really gain self-awareness and try and develop that consciousness. So that was something that was obviously a huge, huge issue. And what that ended up leading to is a series of unfortunate events, literally. So you had this code coming in where most of the team, if not 99% of the team, had no idea what was going on. And in theory, or the way that I like to look at it, is there are a couple things here that went wrong. So first of all of this stuff is happening, and their ops team is freaking out. Their QA team can't figure it out. No one can roll any of the code changes back. So they're just living literally in a nightmare. No one can get out. Like anything that you can imagine that was terrible that could happen, happened. And so, oh, oops. Alex, do you want to change it? Sorry, I might have turned it off. But basically, I think it comes down to yeah, exactly. So I forgot this one was in there. But basically, everything shuts down and their system goes down. And this was all because of one update. So it just shows the power of the code, the power of code that you release, and just making sure that you're testing that properly. And really that you have systems in place to understand, like, okay, when something like that does go out, we can pinpoint that and be like, oh, it was the Reveries update. I just need to roll that back. We'll be totally fine. But that was not the case, obviously. So people were freaking out. Yep. And of course, the worst case scenario, everything goes down. And people are trapped inside the park. So not great. So I kind of hinted at this before, but really I like to kind of run through what were some of the things that, as a team, Delos did not do well. First things first, their quality really began to slip. And part of this is because the hosts that were infected with this new update actually eliminated their head of QA. So in all fairness, she might not have been there. But there really was a lack of feedback, and I think that is the main issue here, is like, when something like this goes out, people should be alerted immediately that, hey, there are anomalies in the system. Maybe we should take a look at this. This isn't something that looks like what it should look like. Errors are coming up that we don't know how to debug. Like, what is going on here? That kind of feeds into team alignment. In Delos, I didn't really bring this up that much here, but in Delos, their teams were so siloed and disconnected. I think everyone was kind of, and I get that it's a show, but this does happen in real life, where people take their individual bubble very seriously, and it's like, oh, well, I do this, so this is not my problem, it's blah, blah, blah's problem. It's like, well, you guys are all, at the end of the day, you're all working toward one ultimate goal. And so I understand it may not be your responsibility, but it is your responsibility to communicate with the members that impact that ultimate goal. So that was an issue. Their testing was extremely limited. So if you'll see, if you watch a show, you'll know, like, they did a few test runs where they sat down with people and would say, like, if we're going to say this, what's your answer? And basically test that response. But it was really being done by one person who had other intentions for this code anyway. Like, they really wanted that to get out. They wanted to see it crash and burn. So if you were able to run a bunch of different tests, maybe with different people, that could have been eliminated as well. Obviously, the code was not reviewed, and it was pushed into production before anybody else had a chance to understand what was going on. Big flag. And then they also had, this is kind of an interesting one that we don't really see as much, but there was legacy software that was released. So one of the characters, I forget her name at the moment, but she actually had been in the park and hadn't got an update in probably years. And so that was something where it's like, maybe you should take a look at that too, because down the line that ended up impacting the storyline and didn't go so well, obviously. So the next thing, I guess, hierarchy that they did really wrong was, and I guess, I know I keep saying that this is the key, but this really was a huge problem, right? Is like, they had updates that deployed and they didn't know how to find out when something went wrong. And even if one person knew, that person was not communicating that to everyone else, to people that may have had knowledge to help them and dig through a little bit deeper and identify what was going on. So those included vague error codes, obviously had limited tracing, and limited testing meant that it was hard to reproduce those problems when they went back to test the issues that they had seen in production. So this is what I would imagine Delos' software development lifecycle to look like. You have, you're doing okay, write some secret code, push it out, everybody freaks out, you try to run some patch fixes, but at the end of the day, that's not solving the ultimate problem because you have no idea what's going on. I don't even know if you guys can read this, but I'll read it out to you just in case. So these are kind of just the key areas where there should have been red flags, right? There should have been alerts going off. You should have had a system in place that's like, hey, there have been a series of things that are not working too well. Let's dig into that a little bit deeper. So first of all, there are some highlights here that I just thought were pretty important from a team organization. If someone goes down in your team, doesn't show up to work, like, I think that you should probably be like, hey, you know what? Are they okay? Like, what's going on with them? But that didn't happen as well. So one of the things that I wanted to call out, or two of the things, I guess, the main things were that Arnold wrote 50% of the code, and then one of their higher level team members was made into a host clone. So you have people going off the rails doing things that really shouldn't be happening. And I know that this isn't as common in normal teams, to that degree at least, I would hope. But just make sure that everybody's on the same page as to what the goal is and what you guys are trying to do. And if they did something as simple as this, everything could have been solved, right? Like, if everybody knew what was happening, if you had some visibility into what code was being pushed, what you were testing, when you were doing it, everything could have been solved. So I can't reiterate enough the importance of really taking in a team mentality of owning quality and having visibility into what you're doing, both in pre-production environments and in production, especially in production is really what I mean. So I showed what I thought that their software development lifecycle looked like. this is what I would imagine or what I would push for as an optimal software development lifecycle. And I know that sometimes it's not as ordered as this, but for simplicity, I kind of just put it like this. But the main thing that I wanted to call out is that this is a continuous process. It's not something that should ever exist in silos, and if it does, maybe that's just a mental thing. Like you guys are people. You have the ability to walk over or Slack somebody and say, hey, I'm working on this. I was hoping to get another set of eyes. What are your thoughts? Very, very simple. But the goal really is to be able to make sure that you're amplifying the feedback that you can get to really continuously optimize what you're pushing into production. And obviously, if you test and if you're able to test and monitor in parallel earlier on in the life cycle, you'll end up saving a bunch of money and effort down the line anyway. So, I recently had people ask me, well, why? What is the point of doing this? I think we kind of get it, right? One of the things I wanted to call out was a line in the show that was like, the only thing stopping the host from hacking us to pieces is one line of your code. And honestly, like in a lot of business critical situations, that may be the case. Like we work with a couple companies that really deliver, I mean, it's more regulated, but they deliver things that is a matter of life or death. And making sure that you're able to feel confident about the quality of your software is essential. And I think a large part of that is your ability to test, your ability to monitor, and then your ability to go back in and say, hey, we did all of these things. This is what's coming up in production, and how can we go back so that next time, when we're working on this, we can make this a better process. And so really embracing quality and observability as a practice, as a cultural, I guess, pinnacle for your teams, what that helps you to do is make sure that you can release confidently, you can release a little bit faster, and then things go smoothly. And then when they don't, you can debug a lot faster and you can reproduce those problems a lot quicker. One of the things that we've seen work, just to address that last one, one of the things that we've seen work from our customer perspective is making sure that you standardize the way that you write code. If you implement code review, it's super helpful. I know that a lot of teams do that currently, but just pushing on that as well and making sure that you promote feedback even within your team and then externally if you need to as well. So big question of the day, why doesn't everybody just do this, right? Like why don't you just go home and wake up the next day and be like, all right, we're gonna go execute on all these things that we talked about. At the end of the day, it can be hard. And I think a lot of it is, some of it is mental, some of it is in reality. It's a lot of effort, it's a lot of collaboration, and it takes a lot of time to do well. But that doesn't mean that it's not worth doing. So it's really important, obviously, to make sure that your team is on the same page, that everybody understands the ultimate goal that you're working to achieve. And then even if you can start little by little, you'll be in good shape. And I also wanted to call out, things are changing, right? In the past, I think implementing a lot of these things was really difficult because it was hard to scale and it was super expensive to do. In this month, like literally in this year especially, I think that has changed drastically. It's not something that's incredibly impossible to do. It does take a lot of coordination, but it's something that you can make scalable and you can do without basically spending all of your budget for the next year. So just keep that in mind when you're thinking about it. All right, so how can you actually actively go do this? And I think the first thing to do is to make sure that you change the way, I think it is a big cultural element, right? So change the way that you would think about or approach these problems. The first one being to think about the output that you're creating. I know that some teams that are more, or I guess better equipped to develop with observability in mind have a lot of success because they're able to go back and say like, hey, we know that we made this exact change for this reason, for this user case. Let's go back in and figure that out. So really take the time to test, and if you can, try and think of building a monitorable system. So think of, down the line, what am I going to need to go back in and do? What are the things that I'm going to care about, and how do I make sure that I have visibility into those things? The next one would be to learn to collaborate and communicate. I can't stress this enough. Obviously, I'm sure that you guys have heard it from me so much today, but it really is important. And I want to call out for this specifically. It doesn't necessarily even have to be within your development team. A good example is, I know that you guys know that I'm on the marketing team, and recently we had a couple product updates where people were trying to figure out how to really prioritize what tests they're running based on data that they wanted to have access to. And a lot of the times, other teams within your company will have access or keep track of different user journeys that maybe you don't know are as popular or as frequent, but other teams within your company will have that data so that you can say, hey, actually, no, that path isn't something that users take, but we are seeing a lot of people do this. So if you want to prioritize running that test over the other test you were looking at, that would be less of a risk for you to spend your time and effort doing. And then finally, I know that this is obviously something that's important, but find tools that match goals for your team and that really are able to fit seamlessly into what you do. I think a lot of the times it's easy to say like, oh, this one sounds really amazing, sounds great, and then you get down the line and you're like, oh, well, we only test internal apps. It can't test internal apps. We need it to be a SaaS-based platform. They only have on-prem, or vice versa. So really just taking the time to make sure that you estimate or understand what your goals are for that. And then to get started, I kind of touched upon some of these already, but just to map it out, I think a good place to start is really defining what your need is. What are some of the gaps that you have? Then prioritizing those, and then making sure that when you go in and you're actually trying to instrument things that will help you achieve observability, make sure that you clarify or that you're really clear in what you're doing. So whether it's creating events that ultimately have logs that roll up into that event, especially if you're not someone that is familiar with that code, just make sure that that's something that you can make as clear as humanly possible. And then, I said it before, really take a tools perspective based off of, or when you're assessing tools, take the perspective of your team. Don't just take one that's like, oh, this is the coolest, newest product ever, this is going to be great. Really understand what's going to work well for you. And then, like I said before, just start. Obviously, it does take a lot of time and effort, but it will be worth it in the end, and it's worth doing properly rather than just trying to get up and running. So I won't spend too much time on this, but we've seen this slide before. But in terms of understanding testing and monitoring and collaboration, obviously we have a suite of testing tools that can help you do that. I know some people in the room use them already, which is awesome. I would highly advise everyone to go try it out for yourself. We have free trials for all of these as well. So really important just to see if you guys, if they fit well for your team, basically. I won't spend a lot of time on that. So I wanted to see if you guys had any questions, and if you don't, that's okay. But if you do, yeah, go for it. I'll walk over with the mic just in case. So you don't have to, well, then you don't have to yell.
No, that's fair. So I'm part of a QA team that has some insight into monitoring, but that's more left up to the infrastructure team, trying to tighten that loop because from my perspective, any fire that we experience is a really good chance to build a fire drill, right? And so I'm wondering if SmartBear or other technologies that you or the room knows about are really good at capturing data from a monitoring perspective in an event, you know, whether that be individual events or things that have been logged or load, and then, you know, being able to take that data and play it back in a simulated way.
So I guess it totally depends on what, oh, sorry, I can't go past this green line, otherwise we're gonna go deaf. So I guess it really depends on what you're using. I would say from a SmartBear perspective, you definitely can. I do wanna call out though, AlertSite is a synthetic monitoring tool, so you don't get that level, that additional level of like APM data, so we don't have RUM in AlertSite, so you wouldn't be able to track that. But if you were looking to understand or I guess replay issues that had happened in production in your test environment, AlertSite does work really, really well with a lot of our test tools in doing that. A good example would be if you guys use SoapUI Pro or LoadUI, AlertSite has a direct integration with that. So you can go in and say like, okay, you can actually reuse the same script if you wanted to create a monitor, and then when something goes wrong, just be like, hey, we had an error at this step, this is the message that we got, can you guys go back and fix that? Or it may very well be the same person running those two tools, which is totally fine. And I definitely think there are ways to do that. It just totally depends on what your tool stack is and how they're integrated, if at all. I know that's not exactly a specific answer, so I apologize. I can really only speak to that. Yeah. And again, like, I'm not even trying to push that, honestly. It's just something that I'm like, you can do that in the tools that we have, but it is good to know, like, you're not going to get the same level of, like, log data, for example, with Alert Site. Like, definitely not. But if you're looking for more performance-based information, that would be super helpful. No problem. Any questions? Okay, if not, without further ado, I will hand it over to Alex. You can do an intro. You want this back?
Hi, everyone, and thank you, Saoirse. That was awesome. I've never actually watched Westworld before, but now I am inspired to. So next up, we have Charity Majors. If you haven't heard of her before, she's just really awesome. She's the CEO of Honeycomb. She was in Boston for serverless days, so I was like, hey, want to come to SmartBear and do a meetup with us? And she was like, yeah, let's do it. So she is going to be talking today about testing in production, the taboo and why you should be doing it and how you should be doing it, and it's going to be really great. So I'm going to hand it over to Charity. After she's done chewing.
Am I supposed to hold this? Oh, there's the clip.
Yep.
Yeah, it totally is. That and plus, like, science just doesn't work that way. You do not do a big bang deploy and then watch for all the things collapse. Like, come on. It doesn't look that perfect. You can't ship it. It doesn't look that good until you've been iterating for quite some time. I'm still hearing a lot of feedback. Is it okay? Oh, is that? Have to be what? Oh, the speaker's right there. I see it. But my wine is here. Just gonna back this way. All good? All right, that seems good. Yeah? Sweet. All right. This way I can see the slides too. Yes, I test in production, and so should you, with caveats. And this is a talk that I gave at ChaosConf. My clicker isn't working. This is why I always like presenting from my laptop, because then I can control the chaos. Hi, by the way, I'm Charity. This is my second talk at a Ministry of Test event, and I seem to be breaking everything. No, I'm not doing anything. I have my laptop too. Do you want me to run it off of that? I am clicking away. Ooh. There we go. Spoiler alert. Okay, there we go. There's me. Oh, fuck, I forgot the stickers. I wrote the book, Database Reliability Engineering. Anybody here have the book? Oh, then I missed out. Okay, I brought stickers. I have them. I'll mail them to you. I don't know if you know this. Can you hear? Now you can hear. Can I click? Yes, I can click. This has been an ordeal. Really has. I believe that AV is like the hardest unsolved problem in computer science. It just never works. Anyway, you cannot have a mythical creature, I was told, as your O'Reilly spirit. I'm not supposed to say that anymore. Animal. So it's a horse, but I have the stickers to turn it into a unicorn. So I'll send you one. Anyway, my career has basically been spent as an infrastructure engineer. I really like being the first infrastructure engineer to join a team of software engineers who think that they have built something that works. And we get to help it grow up and become a real thing. I was at Parse, Second Life. Parse got acquired by Facebook, which is a whole nother story, but let's move on. And now I work at Honeycomb, which was built off of the experience that I had at Parse. So Parse is a mobile backend as a service, where it's like Heroku, but for mobile apps. You did all the backend stuff. We had SDKs. You could make a mobile app without having to learn how to do backend stuff. It was really cool. Facebook killed it, and I'm not bitter. Moving on. You can tell I'm an ops because that's how I feel about software. I believe that code causes problems. The less of it, the better. Just as much as you need to solve your business problem and no more, because code is a liability. I think that testing and production has gotten a bad rap. A lot of people are in denial about the fact that they do it, and so they do it poorly. Whereas if they just embrace the fact that they do it, perhaps they would do it less poorly. It's also like a really great source of memes, so bear with me. I did a lot of them. And I blame this guy. Like, it's such a great meme. It's such a great meme. Everybody knows this meme. I don't always test my code, but when I do it in production. I need to take a drink with that one. It's so cool. But it implies that you can not test in production, that somehow you can ship to production only artifacts that have been battle-proofed. And nothing new can ever happen. I think we should be. It's not a dichotomy. You can do both. You can test before production and then test in production. Or, like I said, there's a lot of memes. Production is where your users are, right? And that means it's the only environment that matters, honestly. We'll round up to say that that's true. I don't have my previous slide, so I honestly have no idea what slide is coming up next. This is like karaoke. Just like, how does this go? But by saying this, I do not mean that this is not an excuse to skimp out on the testing that comes pre-production, right? This is not an excuse to say, oh, well, we don't need any QA if it's all happening in production. No. I am here to help people learn how to test better by including production, not to half-ass it. And I really do believe that because we haven't admitted that we do some amount of testing in prod, we've taken so much energy, all of our development cycles, which are the scarcest resources that we have in tech, and we are devoting them to pre-prod, and we're neglecting production, which is why we have such shitty guardrails, and we have such shitty best practices, and this is why we give the intern the job of write the deploy script when it's like the most important piece of code you will ever write. Our entire idea of what the lifecycle looks like is changing a lot. A lot of people think of deploying code as like a binary switch. It's on or it's off. It's in or it's out. Whereas code, this is supposed to say, releasing code is a process of increasing your confidence over time as it's exposed to more and more scenarios. If you have a piece of code that's been in production for 2 years, you feel pretty good about it. It's been through Christmas. It's been through the holidays. It's been through, it's not perfect, but it's hardened. Whatever piece of shit they're deploying yesterday, you shouldn't trust it. It's in production, but that doesn't mean it's trusted. It's more like baking cookies. You can put them in the oven, but it takes a while before you want to eat them. this is how we used to look at it. Fear my graphic design skills. Development, flip a switch, prod. But increasingly, like, I think of production much more like, okay, here's a journey that we're on. We're starting, we've got to deploy. We've got some rollbacks in there, probably some cherry picks. Whoops, some of those didn't go so well. Well, let's add some, there's the cherry picks and the redeploys, and oops, that one didn't go so well. But we're increasing our, according to our metrics, this feature didn't, it depended on that one, and now we're, going to try and add Chaos Monkey to this. The entire thing is just it's a fucking Rube Goldberg machine as it is. I can swear here, right? Okay, good. Anyway, why now? Well, why is it getting so different now? Why is it that a deploy script that you used Capistrano 10 years ago used to be considered great, and now it's like, what are we even doing here? Well, complexity is increasing. By the way, you can tell I'm a music major dropout because when I do science, it looks like this. But you know it's true because I have a graph. Complexity is increasing, and a lot of this is self-inflicted, sometimes for good reasons and sometimes for bad. Most of you do not need to be running Kubernetes, period. But everybody's systems are becoming like more and more comprised of lots of smaller components, far-flung, loosely coupled, sometimes running on other people's services, but you depend on them for yours. Sometimes, a lot of it is actually lives in the devices. A lot of your wisdom lives in the devices. And now you have how many millions of those? Like, fuck. If we drew an infrastructure diagram, the humble lamp stack, which I always tell people, if you can solve your problems using a lamp stack, please do. Like, it's rock hard. Like, this is the cheeseburger of like systems, right? It will always be there. It will always work. Apache bugs are probably not going to kill your business. This one in the middle, this was Parse around 2015. That was the last infrastructure diagram I built. And like that middle blob is a few hundred MongoDB instances. We let developers all over the world write their own code and upload it to our servers, and I just got to make it work. Write their own queries, upload it to my databases, just had to make it work. Like co-tenancy problems between like noisy neighbors and like it was challenging. You should never do this. It's a terrible idea. But developers loved it. But it's really still just kind of a step on the wayside to, like, this is the national electrical grid. And this is really the kind of system you should have in mind when you're building and architecting and debugging your systems nowadays. It's a distributed system, right? It's very easy for us to see this. It's easy for us to reason about how ludicrous it would be to try and predict that a tree is going to fall on Main Street in some town in Iowa tomorrow, right? No, you can't. You shouldn't try. So there's hyper-local problems all over. There are also problems that you can't see until you zoom way out. Like if all the bolts that were manufactured in 2012 are going to rust 10 times as fast as all the other bolts, right? You can't predict it. You shouldn't try. And it's made up of so many components sitting on top of other components, sitting on top of other components, on top of manufacturers, that you just have to throw up your hands and say, I give up. I give up. I'm not going to really try and predict the problems that I'm going to have, except at a very high level. What I'm going to focus on is gathering information at the right level of granularity that I can ask any new question so I can diagnose and debug any new problem without having to ship new code, just like you were saying, without having to ship new code and wait and hope it happens again, right? This is how we should be thinking about our systems. And I find a lot of people think that this is depressing. I find this liberating because, with a lamp stack, you could predict 80-90% of the problems you were going to have, and over the course of the next year, you would slowly encounter most of the rest, and you'd build up this, ability to look at your dashboards. You'd have intuition. You just glance at it and go, I know, it's Redis, And that makes us feel good. But then you can't go on vacation because all the information about your system lives in your head, and your entire team is fucked if you're gone. Right? This is not good for anyone. It's so much better to just go, I've built this giant thing that mostly works, and I am comfortable with that. I am happy about the fact that I know that there are problems that I don't know about. It's a best effort. I'm in ops. We're pessimists. And yeah, it means a lot to a lot of people, and it does good enough to get the job done. It delivers to people the things that I promised them, and we're just going to incrementally work to make it better, not just for the users, but also for the people who have to run it. Right? You don't want to be dispatching someone from Washington, D.C. to go to Iowa in the middle of the night because a tree fell over. You need to have people on the ground who have estimated that a tree is going to fall over, X amount of times in this state. We need to have this many people, on site, ready to react. It's a different model. And it really matches the shift from monitoring to observability, right? Monitoring is very control-oriented. I can predict what's going to happen. I'm going to write a check for that. It's going to fall between these thresholds, and then I'll repair it. It's all up. It's never all up. And observability is much more about, I need to empower myself and my team, my future self, to understand anything that anyone is complaining about. The moral of the story really is, your system's never actually up. So many catastrophic states exist right now that you just don't know about because your tooling probably isn't good enough. Or you probably even know about some of them, but you don't know enough about them to know how to fix them. You just know that they live somewhere in your system. And that's just distributed systems, like, welcome to the party. By the way, I think this means that you deserve a raise. Just put distributed systems somewhere on your resume, and you get like at least $20,000, pretty sure. The known unknowns used to be most of the things we got paged about, right? You get paged, you go, yes, this again. I'll look it up in my run book. I'll fix it. Write it down. And like maybe a couple times a year, I remember at Linden Lab, a couple times a year, maybe we'd all be stumped. We'd be like, oh, all hands on deck. This is a new unknown. Unknown unknown. It's like, who knows? It could take us a minute. Could take us a week to figure this out. That's not the world we live in now. I feel like nowadays, increasingly, every time you get paged, it should be something that is an unknown unknown, right? Because the total rate of failures is increasing like this, and the number of people we have and our ability to manage them is increasing like this. We as teams have to get better at managing more stuff, and this means getting better at auto-remediating things that can be auto-remediated. This means paying down all that, making sure that infrastructure and reliability are first-class citizens right up there with product. It's not something like you're just finding this time in the couch cushions to patch shit up. That won't work. You will fall behind, and your house will be on fire, right? We need to catch up. We need to pay down that debt so that every time you get paged, it is a bit of a puzzle, right? It's just, this is a new thing. Okay, I'll get up and I'll investigate this. Those are problems worth waking up for, and they should be not that many, right? Otherwise, you're going to be getting woken up all the time because you're going to need humans to push buttons, and that's terrible. Let's not do that. Unknown unknowns are what this game is about. And distributed systems are really hostile to being cloned or imitated for traditional testing, right? When I was at Facebook, what are they going to do? Spin up a staging copy of Facebook to run their tests on? It's cost prohibitive. And the diminishing returns are steep, right? Nobody's going to pay for observability that costs 5 times the cost of production. Not only is it expensive, it's stupid, it's pointless. And I say this with special venom because I come from storage, and I've written the gold standard test for 3 times, where you capture 24 hours worth of traffic and you replay it against a copy of the hardware with various clients and concurrency and tweaking various things for performance testing, which is sometimes worth doing almost exclusively for storage changes. That's it. The rest of the problems it's just not worth it, even if you could. And this, I don't know what that says, but I'm going to guess it. Distributed systems are basically, it's not the same 5 problems. It's like this infinitely long, thin list of things that are basically impossible and almost never happen, right? And these are the failure scenarios that we have to deal with. That, or it takes 5 impossible things to intersect to show this bug. which means that even if you did a capture and replay, you probably wouldn't trigger it. And pouring all of our energy into staging, trying to catch these bugs before they hit production. I know I'm preaching to the choir here, but it's my songbook. It's a black hole for engineering time. You can every unique deploy is a test. You could not test the unique combination of this artifact, this point in time in this infrastructure, and this deploy script, because as soon as you run it again, something's changed, right? This is the irreducible complexity that I like to point out whenever someone tells me that they don't test in prod. You have to. You do. Has anyone who's ever misspelled production when deploying will have figured out? Only prod is prod. And deploy scripts are production code. They're probably the most important code that you ever will write or use because it gets used every day. I don't remember what this. No, staging is not production. Yes. Why? And which brings us to observability. Obviously, any staging environments or pre-production environments that you have should be monitored and instrumented just as well as production, or else the insights that you can glean from them are pretty much useless. When it comes to testing and pre-prod stuff, you can catch 80% of the bugs with 20% of the efforts. The computer scientists say so. I'm not one of them, but Katie has a great talk about this. So it's worth doing, right? The pre-prod test is worth doing. What I'm saying here is that engineering cycles are the scarcest resource that we have or ever will have. And we're devoting too many of them over here instead of actually spending them in production. You need to watch your code run with all of these things. Every engineer who's writing code should be up to their elbows in production every day. If you're only looking at production when things are broken, you're not going to know what healthy feels like or looks like. Engineering is an inevitably intuitive art, right? So much of what we do is, this feels wrong, I'm going to pursue it. This feels okay, right? You trust. To me, basically the definition of a senior engineer is that you trust their judgment when they say things like that, right? And in order to have intuition that you trust, you have to be deep in the environment where the results that you're experiencing are meaningful. When you spend too much time, all your time in staging or other environments that are not prod, you learn the wrong tooling, you learn the wrong responses, you learn that doing things like drop database in a REPL shell is okay, right? That's what we should be learning. All your engineers, you should build a production environment that is resilient to engineers so that they can be knee-deep in it. Because it's not just about finding problems. It's about understanding behaviors and consequences. It's about understanding what your code actually does. I'm sorry, but you run your code in unit tests on your laptop, you do not know shit about what your code is going to do. You only know what it's going to do when you observe it interacting with real users in a real environment, under real scale, real load. That's when you start to know what it actually does. Staging is not equal to prod. Well, that seems obvious. So what kinds of things do we test before and in prod? You do the basics, right? There's no excuse for being sloppy. You don't want to test or ship broken code to prod. So rule out, does it fail the ways that I can predict, or the ways that it's previously failed, which I should be able to predict, right? Does it work? Does it run? Cool. Test in prod, subtle things. You can't really test your deploy scripts off of prod. It's almost not really worth doing beyond the basics. If you have a sizable infrastructure, right? Canarying, which we're now calling progressive deployments, which I really like that term. We've needed a term to really rally around, I think, for a long time. Meaning so at Facebook, the way they would do it is anytime that a build passed Sandcastle with any Facebook people here? Yeah. Anytime that a build passed all the tests overnight, batteries of tests, it would get loaded up in the queue and it would go out first to 10% of Brazil. I don't know what Brazil ever did to them. But oh no, sorry. First it would go to internal. It would go to internal@facebook.com, right? You would inflict it on the internal Facebook users first who worked there. Which is why our version of Facebook went down all the time.
But we would notice, right? Because we did it to ourselves first. Roll it out to ourselves, one region, then other regions, then to 10% of Brazil, then to 50% of Brazil, and on, until it had been rolled out to the entire world, which would take days. And the more paranoid you are about your software, the higher your guarantees to your users, the more you want to invest in something like that, because it's acknowledging and affirming that this is the only way to gain confidence, right? Load tests, all right, this is somewhat controversial, but I do know a lot of people who run a 20% load test at all times in their infrastructure, which is cool, because whenever they run out of headway, they just turn it off, and they've bought themselves 20%. That's pretty great. Load tests that are not in prod are always going to be pretty artificial, and they're mostly restricted to individual components. So I could argue about this for a long time over drinks, but I'm just throwing it out there. I could argue both sides, actually. Behavioral tests, A/B testing, experiments. This is why you need things in prod like feature flags, right? Things for shipping safely. Any code that gets written should get out and exercised as quickly as possible. So if you have features that are being worked on for a long time, the only way to do this is by investing in things like feature flags. Testing DR, testing beta programs, testing. Did you guys read that the Door report where they showed that that the speed and the safety of deploys are not in tension, but they reinforce each other? I love that. You know, it's just almost, it's a smell, right? The more time engineers spend looking at things in staging, and the less time that production is relevant to their work, the worse it is. Like, the worse it should feel. Does that make sense to you guys? Yeah, cool. Yeah. These map to monitoring and observability, right? This is monitoring. It's for known unknowns. You test it. Basics. And these are the unknown unknowns. You know that you can't test it because you don't know what it is. So you put it in prod as quickly as you can, as safely as you can, and you wait to see what breaks. So there are some risks. It makes security teams a little wobbly about this. You want them to be on your side. Data is always where things get scary, right? So the closer you are to a schema change, something that's going to mess with a data format, the more paranoid you should be, and the more traditional offline testing techniques you should incorporate. Co-tenancy risks. If you have a platform, to me, a platform from our perspective means you're inviting your users' chaos to live in your house, right? If they're writing code that lives on your shit, okay, well, that's stuff that's inherently very unpredictable and challenging. But co-tenancy risks are more something to be mitigated, something to be solved through the application of sane limits on everything that people can do, right? Don't assume that they can do anything infinitely, because they will. Just don't let them. The app may die. This is a clean but sometimes deadly thing. You might saturate a resource, which is a good argument for running some continuous load testing through your entire system. And at the bottom is the most important one of all. It may cause a user to have a bad experience. This is what we must prevent, right? You can test and prod all you want, as long as nobody can tell, right? And you guys probably know more than I do about ways to namespace, test users that you use for end-to-end testing that, it should traverse the full code paths, but not impact the users who share their space. So this is a list of some of the things that you can use to usefully do this. Please don't build your own. Please don't. And a lot of these came out of people who had left Google or Facebook and who had gotten so used to leaning on these tools as a way of validating in production what they had built, because you have to at that scale. And so we started companies to give you and everyone else these tools. And a lot of people will go, oh, well, sure, when you're a Google or Facebook sale, then you need these things. No, that's when it becomes impossible not to have them. It makes your lives better. It makes your user experience better. It makes everyone's life better to have them from day one. feature flags, Logic Darkly, high cardinality tooling. All the monitoring system tools out there are geared towards low cardinality data, but things like build ID, high cardinality, if you want to be able to break down by last version and this version, or if you want to have like 50. Facebook has like 50 versions in production at any given time, right? High cardinality right there. Shadow systems. When you're doing a rewrite, it's often really useful to have a splitter in there, right? That sends a request to both an old copy of the code and the new copy, and then returns the old copy to the user and diffs them and lets you know if there's a difference. And you can stack them so that you can do that with database traffic too. Super useful. And if you're doing a sticky database upgrade, then absolutely do a capture replay. But be less afraid. This is almost the biggest hurdle that we have to overcome, is a lot of engineers, and I feel for them, a lot of them are paranoid to touch production. They're scared shitless because they've been yelled at, because they have accidentally broken something and just got chewed out. We have to not do that. Don't chew people out. We all make mistakes. At Linden, we had Shrek ears. I don't remember how this originated, but like we had Shrek headband. And the first time a new employee broke the system, we'd give them the Shrek ears, not to shame them. It was almost like a badge of pride. Now they were a real boy, right? Like, or a real girl, whatever. They had grown up, they had broken. It was great because they'd walk around all day and everyone would get to ask them questions. And they would get to like tell the story of what they tripped over, what they accidentally did. And so we all got to learn, right? And people would be like, oh, that's great. I have an idea for how to fix that. And you could talk about it and everyone would learn. I'm like, it's all in the delivery, right? It's all in the attitude. You can't make it a shamey thing. At Parse, I instituted a tiara. We had a tiara of technical debt that we'd give out weekly whenever somebody did something amazing, like pay down our technical debt. And they have to be conversation starters, right? If you make it a badge of pride, that you were doing something that was important enough that it broke something, and here's how we're going to collectively make sure that you can't do that again. Like, then it becomes a really valuable thing. These are all like guardrails, things that I think of that we can do to help people have confidence when interacting with production. And there's a billion more, and I would really love for people to start talking about these things more, because I'm sure there are tons that I haven't thought of and I would love to know. Be less afraid. Engineers should not be afraid. Production is where you should live. It's where your code lives. It's where you should live. Failure is not rare. It's actually good for us to fail a lot. It's good for us to be aware that we're failing a lot so that we practice it, right? Small, regular failures that everyone gets to mop up with, none of them hurt the user, or users should never be able to notice. This is great. This is great hygiene. We should celebrate this. It's definitely when, not if. So this is what every engineer that you work with should know. Every one of your engineers should know how to deploy, how to roll back, how to debug their code in prod. That to me is software ownership, right? You own your code from end to end. That's how you get we all crave ownership. We crave autonomy. We crave to do something that matters, right? If you read Daniel Pink's research, this is what we want. And engineers who resist being on call are ones who have been hurt. They've been hurt. They've seen us in ops abusing ourselves for too many years, and they're like, I don't want to join that shit show. Like, who would? I'm over 30 now. I don't want to get woken up either. It doesn't have to be a shit show, right? If you're asking your engineers to be on call for their work, like the flip side of this, the job of managers and leadership is to make that job not suck. It's completely reasonable to ask people to support their code 24/7 if they don't have to change their life to support it, right? If getting paid is a rarity, that you're like, oh shit, I'm going to fix this, and tomorrow we're going to post-mortem it because this is not okay, right? And that means leaning on your leadership to make sure that you're carving out enough time as an ongoing thing to work on reliability, to work on, not just patching over problems when they break. Every time you get paid, it should be an unknown unknown. That's the goal. Not having tools to test and fraud is bad. I think this is the end of my talk, I hope. Oh, more memes? Okay. More memes. Tonight we test and prod. There we go. That's the last one. Thanks. Yeah, there we go. Any questions? Yeah. their team is going to quit, and they should. Yeah, they should. That's not acceptable, and it's not better. Like the bar should be lean on SLOs, service level objectives. If the user can't tell, why are you waking someone up or bothering them, right? You should have a threshold, and anything that is under that threshold is fine, right? And then the job is just making it so that more and more and more things can fail without affecting the user going over that threshold. Leaning on SLOs is the best tool I know. You should watch some of Liz's talks. Liz Fong-Jones, she's been talking a lot about this. Yeah. Let's see. I built this about 2 years ago. Let's see if I can remember what I did. Yeah, so we have as soon as you commit your code, it goes into Git, and then it gets automatically pulled down into Circle CI every 10 minutes and builds a new artifact. Artifact gets put in S3, auto-versioned, and then from cron, every 10 minutes, it runs, it checks to see if there's a new version, and if so, it downloads it and impacts it and restarts it. And if the restart failed, it reverts to the last one and lets someone know. You can also deploy by hand. We just wanted to be really sure to get it out as quickly as possible without waiting on someone to deploy by hand. But if you want to deploy by hand, then you can do things like rolling deploys in batches, like split by 5, or yeah. And there's no coordination at this point between any of our services because we want to avoid that as long as possible. Also, for migrations, when I think that all of our migrations are pegged to the web service, so it will, because all the code we write is compatible both ways, obviously. Anytime that the deploy runs on the website, it runs migrations as part of that deploy. We have one or two half-assed. We do production, we have a couple of staging. Let's see, yeah, I remember the Terraform stuff. Yeah, I spun up a couple of staging things, but it's mostly for people to look at things visually. We don't really lean on it for anything other than that. Yeah. Yeah, totally. So Honeycomb, I'm gonna tell you the story of why I started Honeycomb. So Parse, around the time that we got acquired by Facebook in 2015, I was in the middle of a crisis. I was coming to the conclusion that we had built a system that was basically undebuggable by some of the best engineers in the world, doing all the right things, and we were drowning. A couple times a day, a few times a day, a customer would come and be like, "Parse is down." I'd be like, "Parse is not down. Behold my wall of dashboards. They're all green. There's nothing wrong." Because maybe they're doing 4 requests per second, right? Disney doing mobile traffic isn't large, and we're doing 100,000 requests per second. Never going to show up in my aggregates, right? My system is fine. Their experience is that we're down, and so I would dispatch someone, or I would go myself to try and track down what was going on. And because they were writing their own code and queries and uploading them, and there are all the noisy neighbor problems, it could be anything. It would take often days to track down why exactly one user was not having a good experience. And so our feature development had just ground to a halt. And I tried everything out there, every monitoring tool, every APM, every trace, everything. And the one tool that finally helped us get on top of our shit was this tool at Facebook called Scuba, which is butt ugly, aggressively awful to users, hates you, wants you to go away, does one thing and one thing well, which is it lets you slice and dice in real time on dimensions of arbitrarily high cardinality. When I say that, I mean, imagine you have a collection of 100 million users. The highest cardinality dimensions will be the ones that are unique IDs, right? Social security number. First name and last name, lower, but still quite high. Low cardinality would be gender's pretty low, and species, unless you're a furry, will be equal to human. So low cardinality, right? So the problem is that tools out there, they're all geared towards low cardinality dimensions, like tags, right? You have a metric, it's a number, you append some tags that you can group, but you can't have high cardinality tags. You can only have, the right amplification will just explode Anyone here ever blow out the cardinality on Datadog tags? Everyone has. So the problem is that information is not useful when you're trying to track down very fine-grained problems, right? So Scuba, we started getting some data sets into Scuba, and our time to debug these things just dropped like a rock from like days to seconds, like maybe a minute, like every time. Like it wasn't even an engineering problem anymore, it was a support problem, right? Our sales and marketing people who are not technical at all could answer these questions for users. And I can show you some examples or something if you're interested. But like it made such an impression on me that although I immediately was on to the next problem, when I was leaving Facebook, I suddenly went, oh shit, I don't know how to engineer anymore without this tooling that we've built. Like it's become so core, not just to how I look for problems, this is how I understand what's happening in the world. This is like, it's like driving without my glasses and I'm really blind, right? It's like this is how I decide what's worth building. This is how I know if I shipped what I think I shipped, if it's acting the way I think it would act, or if anything else looks weird. Like there's nothing else out there that gives me that very fine-grained look into things. And so we went to start Honeycomb. And at the time I was really thinking this is just a platform problem. It's just a platform problem because platforms have this characteristic where I'm inviting your chaos to live on my servers. And so I need to break down by 1 in a million user IDs and then any combination of everything else, right? All of us have probably done this thing where we have one big user that we really care about, so we're going to spin up a copy of all of our monitoring system for that one user, right? You guys done that? Yeah, right? It's terrible. What you actually want is that for every single user. And that's what we built gives you. Because you can just be like, okay, Disney's complaining. Okay, I'm break down by Disney's user ID, and then by endpoint and latency percentiles. Oh, I see these endpoints are higher latency. Well, those are the write endpoints. Okay, well, which nodes that they're writing to are slow? Oh, okay, it's those nodes. Okay, well, what do they have in common? Oh, it's that availability zone. Oh, I see. It's like following the breadcrumbs. It's a more debugging type of approach than just stare at some graphs and try to be really smart about what's going on. Kind of what? It is, but it's not. It's like BI for systems. Right? Like, can you imagine for your marketing team if you were just like, well, guys, I know you want to know all these fine-grained insights about individual users and stuff, but what you get is a bunch of graphs, and you get to map a bunch of scenarios to see which one best fits the reality that you think you're experiencing. It is insane that this is considered best in class in software today. Yeah, we've been very underserved by our tooling for a long time. And I'm happy to show a demo to anybody who wants to see one, but I feel like I should go ahead and yield my time. Thanks for having me. Oh, yeah, sorry. Yeah. Unfortunately, this is one big, long product pitch. What information from users is most useful? Well, this is why I always tell people to service as many unique IDs as possible so that your user could at least read one back to you or something. Because what you need is you need that fine-grained information because you need to find an example of the problem that they're talking about so that you can look for other outliers that match it or patterns, right? So security teams will fight us a little bit on this sometime, but I think that the risk of leaking too much detail about your infrastructure by surfacing these IDs is much lower than the risk of not being able to understand or explain your systems. Yes. Yes. Yeah. We had this really cool thing called Bubble Up that we just shipped where so the traditional debugging workflow looks like, okay, there's a problem in this spike, And I'm just going to like start going one by one through dimensions to see which one matches or which few match. We did this thing called bubble up where you just, there's a spike, draw a little circle around it, and then click bubble up, and it pre-computes all of the values of all of the dimensions for that plus the baseline for the rest of the time frame. So, and then sorts them so you can see at the top, oh, these 3 or 4 are outliers for that period of time. And it's wicked cool. Yeah, it's that whole, I'm going to debug, and just, this literally cut 90% of the time off of our demo. And I'm just like, oh, wow. Instead of like walking through, I'm now just like, doink, there it is. Oh, that's not much of a demo. So, yeah. All right, thanks for having me.